So we've done linear for the whole first semester. Now we're going to start quadratic functions. So let's talk about what a quadratic is. The linear parent function, as we have talked about, I'm just going to write this down here. The linear parent function is y equals x. It was that line that goes through the origin, has a slope of 1 over 1. So this is the quadratic parent function, y equals x squared. So all the quadratics we do in Algebra 1 are going to have an x squared. So let's go to your calculator and go to y equals, and let's put x squared, and let's graph it, and let's see what it looks like. So this is what it looks like. It has a point 0, 0. Oh, let's make sure we graph it carefully. Let's go second graph and look at the table, and let's graph a couple of points. You can see that there's 0, 0. Let's do one on this side. How about 2, 4? And let's do one on the other side. How about negative 2, 4? That gets us the width of it, correct? So let's graph. This always looks like a reindeer to me. Let's graph the parent function. So this is the quadratic. It graphs like a U. It's U-shaped. And the parent function has this point 0, 0. So let's talk about the characteristics. So the vertex is a very important part of the quadratic. The vertex is the lowest or highest point. Now in this one up here, it's the low point, isn't it? If it's the lowest point, it's called a minimum. Minimum means low. If it's the highest point, it's called a maximum. Maximum means high, the highest point on the graph. So in this particular one, the vertex is the point 0, 0 on the parent function. Now the axis of symmetry is a line. Remember that it's a line that cuts the parabola in half. Oh, I didn't tell you these are called parabolas. The quadratic function, the graph of a quadratic, is called a parabola. So the axis of symmetry is your line that cuts the parabola in half. Now, since it's a line, it's got to have an equation of a line. This one's a vertical line, isn't it? And it's actually the y-axis. So, and we draw it kind of dashed because it's an imaginary line. This one is x equals 0. Remember how every vertical line has only an x. All right, the roots. The roots are a very important part of a parabola. It is the x-intercepts. Now, other names for the roots are solutions and zeros, because it's where the y value is 0. X-intercept, solutions, zeros. You need to know this, that these all mean the same thing. Roots, x-intercept, solutions, zeros. There can be none, or 1, or 2. This parent function has 1, and it's actually the same as the vertex. So the root and the vertex are the same. And then the x, I didn't tell you, the axis of symmetry always goes through the x of the vertex. We'll do that some more in a minute. Now, the y-intercept is where it crosses the y-axis. And in this parent function, the y-intercept is where x is 0, but in this parent function, the y-intercept is also 0, 0. So the parent function has the vertex, the root, the y-intercept all at the same. I should have taken this off. I don't care about intervals. And then let's look at the domain. The domain is the x values, right? And Dixie tells us that. And the range, Roy D tells us, is the y values. So in this one, does x have any boundary on the left or right? No, it goes forever and ever and ever to the left and right. So the domain is all real numbers. The range stops at the vertex because what? That's your lowest point, your minimum point. So the range stops at 0, and then it gets bigger and bigger and bigger. So remember that this means all real numbers. All right, there's your important parts of the parabola. These are all your important parts. The parabola, U-shaped, it's called a parabola. All right. And if we looked at that table of values a while ago, I do want to do this. If we looked at that table of values on your calculator, you would have seen like -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. That's just a piece of it. Do you see the symmetry here? Do you see how the y values are the same, and then they're different at the vertex? So let's look at some examples. So first of all, let's put this in y equals. So let's go to y equals, and let's put x squared plus 2x minus 8. Go to the table. Let's see if we can find the vertex. Let's look at our symmetry. Look for symmetry. If I arrow up some, I'm going to find even more. Look, 16, 16, 7, 7, 0, 0, -5, -5, -8, -8. Oh, there is the point that's different. It bottoms out or tops out, either one. This is your vertex, the one where the symmetry stops and it turns around. Do you see how it's going -6, -5, -4, -3, -2, -1, 0? Then we turn around and go back up. 1, 2, 3, 4. So that's your symmetry point. So your vertex here is -1, -9, and that pen is dying. -1, -9. Let's graph that. -1, -9, way down here. Okay. Axis of symmetry is the vertical line that goes through the vertex and cuts your parabola in half. Since it's a vertical line, it's an x equals. And it has to be the x value of the vertex because it goes through -1. So x equals -1. There's your axis of symmetry. Your roots. Your roots are where y is 0. So I see 2. Let me put it over here. -4, 0. And where's the other one? 2, 0. We find them in our table and we graph them. -4, 0, 2, 0. What's your y-intercept? It's where x is 0. Your y-intercept is 0, -8. So 0, -8. Now, if there's a point here, 1 away from the axis of symmetry, then there has to be a symmetrical point here, 1 away. Let's draw our parabola. We have enough points to draw it now. Still looks like a deer to me. So the domain of every parabola in Algebra 1 is all real numbers. We only do up and down parabolas, up and down U's in Algebra 1. In Algebra 2, you'll do sideways. We only do Algebra 1, therefore the domain's always all real numbers. The range, this one has a minimum. It goes up. It's getting bigger and bigger. Y is greater than or equal to the bottom point. The bottom out point is your vertex. So go to the y value of your vertex, and that's your range boundary. All right, let's do another one. Now, if you don't have a calculator like this at home, remember that Calculate 84 is a free graphing app. Tabulator is a free graphing app for your phone. All right, let's do 1/2. And then put your parentheses, x minus 3 parentheses squared. This one's a weird one. They have the x in the parentheses. Let's go to the table and let's find our vertex. Now we're going to see some fractions. Oh no, fractions. It's okay, because I'm still looking for the symmetry. There it is. Do you see 0, 0, -3 halves, -3 halves, and 3, -2? That's your point where the symmetry stops. So 3, -2, and the axis of symmetry is the vertical line that cuts your parabola in half. X equals 3. We always use the x value of our vertex. The roots, this one's going to have 2 roots. Let's look at where y is 0. So here we go, 1, 0, 5, 0. 1, 0, 5, 0. Those are my roots. 1, 5. And then what's my y-intercept? It's where x is 0. It's 0, 5 halves. That one's not so easy to graph, but I have enough to graph right here. As long as you have your vertex and your roots, you can draw a graph. The domain of every parabola in Algebra 1 is all real numbers. The range of this one's going up, so we're going to have greater than or equal to, use the y value of the vertex. All right, one more example. So type it in your calculator. Now, there are ways to do this without the calculator, and don't worry, I will teach you. Because some of them, you can't find the vertex in the calculator because it's not an integer. So not to worry, we will find lots of ways to do this without the calculator. So let's put it in there. Let's go to the table. Let's find, we're going to have to arrow up. We're going to have to move around. Here's symmetry. Negative 50, negative 50, negative 32, 18, blah, blah, negative 2, negative, there it is, negative 4, 0. Now, that is the x-intercept. Your vertex is an x-intercept. That means it's also your root. That means this one sits on the axis and only has one root. Axis of symmetry, x equals negative 4. Domain, all real numbers. Range, well, we don't know which way this one's going yet, do we? So, y-intercept. Where's the y-intercept? It's where x is 0. 0, negative 32? I can't graph this here. So let's graph a couple of other points. Let's go negative 5. I can write that down. Let's write it down. And let's look at a couple of other points. I have, let's do negative 5, negative 2. And let's do negative 3, negative 2. This. What did I do wrong? I put it on 6. Okay, this one's upside down. It has a maximum. Our vertex is a maximum. It's upside down. I want you to notice something. This negative's what made it go upside down. We'll talk more about that later. So since it's upside down, y is getting less than or equal to the y value of the vertex, which is 0. So there are some ways to identify from the calculator the characteristics of a parabola.